Yay.
Okay, guys. Those of you who weren't here on Kairos, all this stuff is online, so make sure you take a look at that. We're going to have a group quiz over it tomorrow. We'll go through the rules here. Some of you guys have done it before, just kind of listen again. I'm sure it won't hurt. The first rule, you see what the problem is here? We have two batteries that are going kind of in opposite directions, and with resistors and everything. What we're trying to find is the current in each branch of the circuit. So we're trying to find the current through this middle branch, through the top branch, and through the bottom branch. So the first rule is that through each one of these junctions here, where all the wires come together, the current going into those wires has to equal the current going out of those wires. Does that kind of make sense? And we don't need to know anything before we just make a guess at it, what's going to happen. And if that guess is wrong, it just affects the signs at the end of the problem, and it's not a big deal at all. So the first thing we want to do is we want to say, I'm going to call that I1. So we'll say I1 is going into that junction, I2 is going out, and I3 is going out. So we have I1, current 1, going to this center branch. I2 goes all the way around this branch, and I3 goes all the way around that branch. Does that make sense, everybody? So what we're going to end up doing is we end up solving, we have three equations, and we end up with three unknowns, and we solve all of them to find each of the things. So our first equation is going to be I1 equals I2 plus I3. So the current going into that junction equals the current going out of that junction. That makes sense to everybody? Okay. Next thing we need to do is, for the batteries push current out the positive end and take it back in the negative end of the battery. The long side is the positive end of the battery, the short side is the negative. So the batteries are pushing current toward the large side. So we draw little arrows on the batteries pointing toward the larger side of the batteries. Does that make sense? Abby?
Isn't that because negative means that it's moving or something, right?
Okay, the question was about why the current goes out the positive end of the batteries. Remember that we draw current like it's positive charge moving, even though that's not actually what happens. Remember they guessed a long time ago and guessed wrong, and we've just stuck with it ever since.
Okay, yeah.
Okay, so the current's going out of the positive end of the batteries. Now what we do next is we draw loops around each kind of section of the circuit here. So you see how we can go from here and all the way around as a loop, and here all the way around as a loop. Does that kind of make sense to everybody? So it doesn't matter what direction we draw the loop. We'll get the right answer either way, so I'm going to draw this one that way. So what that loop means is that our loop is going around this box part of the circuit like that. Does that make sense to everyone? Okay, now one important thing about this is when the loop and the voltage are in the same direction, V is positive. And when the loop and the current are in the same direction, I is negative. This will make sense shortly when we actually do it. And if the loop and the thing are in opposite directions, V is negative, or yes, negative, and I is positive. Alright. So we already have one equation. For each loop in the circuit, all the voltages that drop add up to 0. So we go through and we find voltage for each piece of the wire. I'm going to start at this 61 volt battery here. So, to the bottom, we have, shut off the 61 volt battery. Is the battery pointing in the same direction or the opposite direction as the loop? Same. So, if it's in the same direction, V is positive. So we start off with 0 equals positive 61 volts. Make sense to everybody? We just pick, doesn't matter where you start, I usually just start with the battery at the bottom because it makes more sense to me. Elena?
The loop was the direction you guessed, right?
The loop is this direction right here.
So you can
I know,
put
but
it
you
in
guessed
either
that one.
direction.
I just made that,
You just made it go that way.
it can either go clockwise or counterclockwise, it doesn't matter.
So you could have chosen either
I
way.
could have chosen either way. If you always, like, what you choose are the loops and the current directions, and you can always just do it the way I did it here, and it'll always work.
Okay.
Or you can try to guess which way it's actually going. It doesn't matter. So if you always draw these arrows like this and always draw this arrow like that, it'll always be fine. But if you draw it a different way, it'll still be fine. Does that make sense? Okay. So next thing we're going to do, we go to the next part of the circuit, which is this resistor. And how do we find voltage using current and resistance? V equals
IR.
IR. We're going to do I3, which is the current through that resistor, times its resistance. And is that current the same direction or the opposite direction as the loop we drew? Opposite. Does everybody see that? So right here, the loop is pointing up, the current's pointing down. So if in the opposite direction, we make I positive. So we're going to say plus I3 times 24 ohms. Anybody have any questions on where these numbers came from? So all we're doing is we're going around this box in the circuit. I just start at the battery. It doesn't actually matter where I start. Start at the battery. It's a voltage source, and it's pointing in the same direction as the loop. Does everybody understand that? The battery, like, if you draw that little arrow, the battery's pointing that way, the loop's pointing that way. Does that make sense? For this resistor, the current through it is pointing down, the loop is pointing up, so it's opposite direction. Does everybody understand the direction parts? Oh, yeah.
Why is the whole thing equal to 0?
Why is the whole thing equal to 0? Because if we start this battery, it's going to start out at 61 volts here. When we go all the way around this, it's going to be back to 0. So like, it's always true in a battery. One side is whatever the voltage of the battery is, the other side is 0. Any other questions about what we're doing here? Okay, now we're going to move on to V2, because that's the next thing in this kind of blocks of the circuit. Is that the same direction or the opposite direction as the loop? Same. So see in the top part, the loop is pointing to the right, and the battery is pointing to the right. Everybody understand that? So if they're in the same direction, is voltage positive or negative? Positive. So we're going to add 59 volts. Alright, any questions on that piece? Next we're going to do R2, and that's going to be same direction or opposite direction as the loop. So what current's going through R2? I1's going through R2. Does that make sense to everybody? Because I1 is through that whole middle portion. And I1's going that way, and the loop's going that way. So opposite, so if it's the opposite direction, what is current? Positive. So we do plus I1 times 20 ohms. Questions about, everybody understand where the numbers came from? Okay, so 61 volts just came from this battery. 24 ohms just came from this resistor. 59 ohms just came from this, 20 ohms just came from this. So what we did is we took this bottom box here, and we have to use every piece of that box. So we have to go through each one of them like that.
So you're just adding all the numbers together.
All the
We're
voltage.
just adding all the numbers together. And whether we're adding or subtracting, it comes down to what they are in relation to this loop we draw. So in this case, they're all positive because both batteries were in the same direction, and both resistors had their current in the opposite direction. Does that make sense? Any other questions? Kira?
The arrow for, like, where the battery is, I think
Is it always, the arrow's always pointing towards the bigger end?
Arrow is always pointing towards the bigger end of the battery.
Okay.
Okay, so let's do the top. Before we do the top, we need to combine these two resistors. Are those in series or parallel?
Parallel.
Parallel. Somebody want to do that for me?
9.08.
9.08.
Oh.
What we can do, since we're not asked about like any of the individual things about the resistors, we can just erase them and just make that one 9.08 ohm resistor. Questions about that? Alright, I'm going to draw the loop in the same way I did before. So the loop, I'm going to just go around like
You
this.
just take away.
Alright, so we start with, put top up here just to make life a little easier and more sensical. So we start with a 0 equals, we'll start with this battery. So the 59 volt battery. Is that in the same direction or the opposite direction as the loop? Opposite.
So negative.
So it's negative 59.
Yeah, it is. Follow his rule.
So do you see how the battery's pointing that way
Yeah.
and the loop's pointing that way?
How did you
It's going
decide?
the battery.
That the loop, how did I draw the loop?
No,
The battery goes this way. This
I don't like
it goes in the
the
battery.
I1 is pointing one way, but then the battery is pointing another way.
Okay, so the I1 we drew is arbitrary.
Okay.
You can draw it either way. If you want to make your life probably easier, just draw it like this every time you do one of these. The battery one always points toward the bigger end of the battery.
I know.
That help. And the loop again is arbitrary, and if you want to just draw it this way every time, that's fine. Okay. So any questions about the negative 59 volts there? Alright, now this 9.08 ohm resistor. What current goes through that one? I2. So, and is I2 in the same direction or the opposite direction as the loop? Same. So what do we do with that?
Subtract.
Subtract. We're going to say minus
Yeah, I know.
I2 times 9.08 ohms. Questions about that term? So again, this one, I2 goes like all the way around like this, and then back to this point. So this is I2, this is I2, this is I2. And the last thing in this one, that 20 ohm resistor, oh, Elena?
Like for on the bottom box, would I3 that goes all the way around as well?
Yep, I3 goes all the way around as well, just like I2. So for our last piece in that top box is the 20 ohm resistor. What current's going through the 20 ohm resistor?
I1.
I1. Does everybody understand why it's I1? I1 is through that whole set middle part. And is I1 in the same direction or the opposite direction as that loop?
Same.
Same, so what are we going to do with it? It's negative.
I thought that the I1 just would do the part to the left and I2 is the bigger part.
I2 goes through this whole part to this point. I1 is the whole middle. I3 is all the way to there.
Okay,
Does that make sense?
I think so.
So as soon as like the circuit branches, that current stops.
Okay.
So this is going to be minus I2 times 20 ohms. Does that make sense to everybody?
Wasn't it I1?
Yes, thank you.
Yeah.
I1, sorry. Alright. Questions about how I found any of those? Okay, now what we're going to do is we have three equations with three unknowns. You can solve it however you want. You can use matrices if you want. That's probably more trouble than it's worth. You guys probably don't remember how to do that. What I'm going to do is just solve each of these equations in terms of I1 and plug them back into this one. So let's do the bottom one here first. We're going to solve it for I3, so it's in terms of I1. So what I'm going to do is I want to keep I3 positive, so I'm just going to bring everything else over to the other side. So we get negative 61 volts minus 59 volts minus I1 times 20 ohms equals I3 times 24 ohms. Any questions about that part? I'm going to combine these two terms and kind of flip these around a little bit. So this ends up being negative 120 equals minus 20 I1 equals 24 I3. Now, one piece of advice I'm going to give to you guys who haven't done this yet is make sure you use decimals instead of fractions. It'll make your lives easier. If you try to find terms and things like that, it gets kind of ugly. So we're going to divide everything by 24. We get negative 5 minus 0.83 I1 equals I3. Any questions on the math I did there? Everybody okay? Alright, can I erase that part? We need some more board space to do the top one. Oh, one other thing I want to mention, guys, before I forget, is you see on the bottom part we have 1, 2, 3, 4 pieces. It means we should have 1, 2, 3, 4 terms. Top one we have 1, 2, 3 pieces. So on the top we have 1, 2, 3 terms in the equations. Right?
What are you referring to as a piece?
Like a resistor or a battery.
Okay.
My question was, for those of you on video, what was I referring to as a piece? And a piece is either a resistor or a battery. Can I erase this bottom part now, guys?
Yes.
Alright, now we're going to do the top. So I'm going to bring I2 over to this side to keep it positive. That's what we want to solve for. So I2 times 9.08 equals negative 59 volts minus I1 times 20 ohms. Alright, now I'm going to divide everything by 9.08. You guys are going to need to help me with this one. What's 59 divided by 9.08? And what is 20 divided by 9.8? 2.2. 9.0 is what I should have said. I1. Michael?
How many decimal places should we do?
Those rounded.
In general, the tens place is going to be fine.
Alright.
Hundreds place will be a little safer, but I mean, you do have some variation if you keep everything or not. So I understand that when I'm grading this. Okay. Can I erase this one? Alright, so now we do I1 equals, what do we get for I2 when we solve for that?
Negative 6.5 minus 2.2
Two.
I1.
I1.
Plus, what do we get for I3 when we solve for that?
Negative 5 minus 0.83 I1.
Alright, so now we just solve this for I1. We bring the two I1 terms over to this side. One thing that's important to remember is that this I1 has a 1 in front of it. So we do 1 plus 2.2 plus 0.83, and we get 4.03 I1 equals negative 11.5. Questions on what I did there? I just combined negative 6.5 plus negative 5 gives me negative 11.5. 2.2, add that to each side, we get 3.2. 0.83, add that to each side, we get 4.03. So now we solve for I1, and what does I1 equal?
3.8.
What?
Did I do that wrong?
Yes.
Okay, sorry.
Is that?
Negative what?
2.85.
Negative 2.85.
Yeah, that's what I got.
JK.
It's okay.
Okay, So I1 is equal to negative 2.5 amps, so that's one of our 3 answers. The other answers are pretty easy to get now. So that's that going across there. Since it's negative, it means that the actual current through there is going that direction instead of that direction. So it's the opposite direction where you drew it. That doesn't matter at all. All we're looking for is the total value of I1 going through there. So all I'm looking for is the absolute value of your answers. Ellie?
So it doesn't matter like to have negative 6.5 V, like the V's and the I's don't.
It usually gets, if you start adding the V's and you think that's a variable, so I would suggest keeping them when you write out the whole equation, and then dropping them when you get in here, because then you've got like ohms and V's and I's, and a lot of times you guys get confused when you have lots of letters.
True.
Okay, so now, what was the equation we got for I2 earlier?
What?
What was the equation we got for I2 earlier?
6.5 minus 2.2 I1.
Yeah, 6.5 minus 2.2 I1. So now we take the value we found for I1, substitute it in there. Negative 6.5 minus 2.2 times negative 2.85. And I2 equals
12.77.
negative 12.77, because we got double negatives here, so we gotta end up adding.
Is it negative 0.23?
Yeah, I had 0.23.
Negative 0.23 amps. And then I3 we found before equals negative 5 minus 0.83 I1. I3 equals negative 5 minus 0.83 times negative 2.85. And I3 ends up equaling what?
Negative 2.63.
One second, Ellie. Ellie?
Negative 2.2 plus negative 0.83, wouldn't that be equal to 3.03, not 4.03?
Right.
From
There's
the,
an
Oh,
imaginary one.
there's a 1 in front of this, like I said. So this is 1 I1, not 0 I1. Does that make sense?
so the variables do matter, you can't just drop them.
You can't. Well, no, the variables don't matter. This is actually I1. So this is like, well, this is a variable. Sorry, the variables do matter. The
Do that.
units at the end don't. So this is like 1 I1, 2.2 I1, 0.83 I1. So we add all
drop
those.
volts, but not current.
No, we didn't drop volts. We dropped the unit volts. Like these, this is still 6.5 volts, but I didn't want to add a V in there because I was afraid it was going to confuse you.
Yeah, I know.
Because the label for current is amps, so.
Any other questions? Okay, why don't you guys try doing number 4 on this sheet? You'll be fine. I'll come and help you.
Nice shot, Mike.
Sean, what do you keep talking?